Just letting everyone in from the waiting room. We'll get started here in just a moment. All right, well, I will go ahead and get things kicked off for just a minute after the hour. I know some folks may be coming in a little bit late. This training is going to be recorded, so if you miss any of it, don't stress. You'll be getting an email from us here with the recording as well as the slides. Today, we're going to be focusing on heat pump water heaters and the current and upcoming energy code. Go ahead to the next slide. Thanks, Jennifer. So just a quick bit of background on the Central California Rural Regional Energy Network. We were approved by the California Public Utilities Commission in September of last year with a budget of $36 million over 3 years. The County of San Luis Obispo is the lead administrator for CCRN, and they work with partners to implement our programs and complete reporting. Currently, CCRN offers 6 programs primarily designed to serve hard-to-reach customers and disadvantaged and underserved communities. Just a little bit of background on who's involved behind the scenes for Central California Rural REN. My name is Jess Blackwell. I work at the High Sierra Energy Foundation, which our organization does lead the Codes and Standards program for CCRN. And we work with the Association of Monterey Bay Area Governments, AMBAG, on the Central Coast, as well as the San Joaquin Valley Clean Energy Organization in the Central Valley. As mentioned, County of SLO is our administrator, and the County of Ventura helps us in an advisory role. And just a quick overview of our other programs. You guys are all here today. We're working on Codes and Standards, which is training and technical assistance for building professionals. We do also have a residential program that works on energy audits and installs simple measures, as well as a workforce education and training program, primarily designed to train youth. We have a commercial energy improvement program, which offers no-cost electrification projects for commercial customers, and a public agency program that supports specifically Monterey Bay hard-to-reach public agencies. And lastly, finance, which will be launching in 2026. So stay tuned on that program. And then I'll hand it off here to Jennifer and Grant from Inbound Green Consulting.
Hey, welcome everyone, and thanks. I think it looks like so far we've got a small-ish crowd so far. So if you wouldn't mind in the chat, would you give me a little bit of information on whether you're like a plans examiner, code enforcement, architect, designer, or homeowner? And I can kind of cater a lot of what we're going over today to your specific needs for heat pump water heaters. Go ahead. Was there, Grant, did you start to say something?
Nope.
Okay, I thought I heard something. Sorry about that.
Yeah, feel free to, open mic if you want, ask a question, or I'll be on the chat. So you can ask questions there, or just let me know and I can interrupt Jennifer as we're going.
Yeah, and we like that. We like the dialogue. We like to have people participate. So please participate with this. Grant and I are both with Imbalance Green Consulting. We do a lot of energy consulting, lead certification, energy performance modeling, and we do energy coaching or code coaching, and we're also education providers for CCRN. And part of what we do for the standards programs is online training like today. We've done some in-person trainings in Monterey. We hope to expand that. And we can do topics on request. And we've also done some specialty services specifically around ADUs, since that there was that big push the last couple of years to get counties and cities up and running with their ADU plans. For the energy coach and code coach services, this is available to plans examiners and inspectors, architects, designer, builders, project homeowners. It's available to everyone. It's free. A little bit of your ratepayer money for your electric utilities and gas utilities goes into a pool of money, and then that money goes back out to kind of harder to reach communities, and CCR Ren then does that work to help support everybody with the energy code and Cal Green Code. So it's easy. You fill out a form online, then we'll respond to you in 1 to 2 days, and we can do follow-up phone calls when requested. So with that, I'm going to get into today's presentation. And if you are an architect, you can get 1.5 AIA learning units for this. And if you are ICC, you will get your 0.15 CEUs for it. Today, we're going to kind of look at give a little bit of background about the energy code in context. And then because we get a lot of questions about heat pump water heaters in general, and I'm not sure what everyone's skill set is on the call, I am going to just kind of review water heater types and then how that's different from a heat pump water heater. Then we'll dive into the mandatory measures that are new for heat pump water heaters under the 2025 Energy Code. And then we're going to go over some of the code requirements, some guidelines, and I'm going to show pictures of examples of installation. And then we're going to hit a little bit more on some of the plumbing distribution, pipe insulation requirements, what happens if you have a recirculation pump, how does that impact your Title 24 Energy Code compliance, and then we'll give you a couple resources and we'll wrap up. Okay, for the energy code in context, big picture, just this is kind of a reminder for folks, again, depending on what your background is, this may or may not be a review, but Title 24 is a huge collection of parts that go into making up the building code, and specifically Part 6 is the energy code. But just as a heads up, coming up in 2025, Part 7 is currently vacant, but in case you haven't heard yet, Part 7 is now going to be the California Wildland Urban Interface Code. And today, however, we're really focusing on the energy code, and then that's going to be applicable to electrical and plumbing code. And today we won't really cover Cal Green, but Cal Green is usually one of the topics that we would address in other webinars. The energy code gets an update every 3 years, and January 1st, 2026 is when the new code cycle is coming into play. And some of you may have heard that the residential portion of the energy code that's coming into play, that's going to be called the 2025 Energy Code, will stay in effect for 6 years instead of 3 this time around. But the other parts of the code will be updated. So big picture for the energy code is, according to the California Energy Commission, is to support a clean energy future for all. So a lot of heat pump technology is encouraged for both space heating and water heating, and a lot of updates on the solar requirements in non-residential occupancies have been expanded. And there's a number of code updates that we're going to encourage energy and water savings by reducing the water that's used in homes and non-residential buildings. And by that, I mean like how much water a chiller uses in a non-residential building. So it's more into the weeds of that, but kind of big picture prescriptive for 2025 code is that residential is that our heat pump space heating, it's going to be a prescriptive requirement. And there's going to be some new requirements around fault indicator displays for heat recovery ventilation systems. And also for today, heat pump water heaters are going to be a prescriptive requirement, which means you can install an appliance that uses gas, but that house will be compared to a building that uses a heat pump water heater. For a lot of our clients, we'll get questions about what water heaters are out there, and mostly because they're trying to figure out the differentiation between what they might already have in their house or what they're familiar with and what is a heat pump water heater. And also, when you go online to look up something about heat pump water heaters, the manufacturers will often list them as electric water heaters and hybrid electric water heaters. And so that adds a bit to the confusion. So today we want to help clarify that heat pump water heaters are electric, but they're different from electric resistance. And heat pump water heaters are often called hybrid water heaters because they're heat pump and electric resistance, but there's no fossil fuel, no natural gas, no propane involved with the heat pump water heaters. A lot of, we still get a lot of questions about how do heat pump water heaters work, and can they be used for replacement water heaters, and questions about what size they should be used. That's, there's a little bit, we have a little bit of information on sizing, and I'll kind of interject that as we go through, but that's something that concerns a lot of folks. And a lot of people just want to know if it's easy to replace their existing water heater when it comes to alterations. In case you're not familiar with the heat pump water heater, they are very cost effective. They do pay for themselves. They are more expensive than the other types of water heaters, but the price is coming down. They have a lot less greenhouse gas emissions compared to standard gas and electric water heaters. They're 2 to 4 times, and the newer ones are easily 3 to 4 times more efficient than like your standard electric resistance water heater. And they're basically a refrigeration system. So for a while, Reem had this video you could watch. I took a screenshot to use it to label the parts, but there is a fan associated with it, which does make some noise. We're going to talk a bit about that. And that fan pulls air from the room, which is warm, through a cooling coil, or evaporative coil, sorry, and absorbs heat from the air. And then what's ejected out is air that now has lost its heat. So it ejects out cold, dehumidified air. And that, because of that sort of physics of how that heat pump works, then that sets up this appliance for some specific design considerations. And currently there's a lot of brands on the market to choose from. Well, I say a lot. Some of them, like Reed, Rudd, together, they each have their own brands, kind of same mother company. A.O. Smith is the mothership for Lochnavar and State. Seibel, Eltron, LG, Sandin. There's other brands out there, but this is kind of the current market for the residential heat pump water heaters. So depending on where you live, it will kind of determine which of these brands you're most likely to find at Ferguson's or Lowe's or Home Depot. And within that system, there's 2 types. There's an integrated heat pump where the heat pump's on top of the tank. We'll mostly be talking about that, but there is a split system called the Sanco 2. It used to be called Sandin, where the compressor condenser is outdoors and just the storage tank is inside. And I'll kind of go through that. So when you take a look at your heat pump water heater, you got the heat pump that's on the top. It's got electrical connection, usually 30 amp electrical connection, the big storage tank, and then you're going to have the inlet and the exhaust vents. And you'll need electrical connection, but there's no gas connection, no flue. And then there is a 120 volt plug-in variety that some brands make. This is one where you would say you might be thinking that a 50 gallon or nominal 50 gallon, maybe it's a 65 gallon actual tank is the appropriate size if you're used to having a family of 4. And then with this 120 volt plug-in, the word on from folks who use it is that you should upsize. So you'd go up to the next one, like the 80 gallon tank. And those are pretty big, but keep that in mind if you're on the design side of it. For the split system, there's no heat pump on top. It's just a storage tank. There is the outdoor condenser compressor unit with its electrical. It's usually only 15 amp dedicated circuit needed. And then insulated water lines will connect the storage tank to the heat pump. Again, no gas. Now, electric resistance is kind of what we're used to seeing when we think of electric. There's no gas line, and tankless. Is also just a high-powered electric resistance with multiple chambers for electric resistance. And then your electric tank, again, there's one big giveaway is there's no like digital kind of heat pump control panel, and there's definitely no vents, and there's no split system outside. And then when you're in an existing house or home and you're wondering what kind of tank there is, one of the big giveaways to differentiating from a gas appliance is there's going to be a flue or something that vents to the outdoors. If you see that, you don't have a heat pump water heater. And then once you get a heat pump water heater, you no longer have to vent to the outdoors. Flue or combustion gas, you may have a ducted heat pump. We'll show you pictures of that, but it looks different. And it is just to be able to duct that air that's pulled into the heat pump unit and to push the exhaust air out of the heat pump unit. So again, you aren't going to find the gas connections on the heat pump water heaters. Now, in the current code, you can choose in new construction to install a gas water heater. But if you do, and you can, get that home to pass Title 24, pass the energy code, you're allowed to do it. It passes, but then the electric ready requirements kick in. And those electric ready requirements dictate that you set up the electrical infrastructure, both in your panel and within 3 feet of where that natural gas unit is, so that you can, in the future, connect up an electric heat pump. And Grant, if there's any questions, or if any of you have any questions, feel free to jump in, because like I said, we don't have so many people in here that we can't cater a little bit to what people want. And I'm just now, okay, I'm going to stop here for just a second and glance at, okay, we have building inspectors, inspector. Oh, great. Okay.
Yep.
So.
Mostly code enforcement.
Cool. Yeah. Okay. Good to know. Okay, so that's a bit of a background. Share the background with you. In many cases, if you're already doing building inspection, this is stuff you may already know. But then if you ever interface with other people on the job site or homeowners, I'm finding they They don't really know any of that. And so they really aren't sure what they're looking at when they see these systems. And so heat pumps are still relatively new for the hot water heating. And because of that, 2025 Energy Code, they went out of their way to actually define heat pump water heater types and be more explicit on what by definition their types of heat pumps they're talking about. So for example, integrated heat pump water heater is defined, and that's like the residential scale, commercial scale units we were looking at. The split refrigerant heat pump means it is a split system, but refrigerant line is being used between the outdoor unit and whatever is happening inside the building, including heating your hot water. And then the split hydronic heat pump water heater is heat pump water heaters that have the outdoor condensing unit outdoors, or it could be undercover, like in a big parking structure, parking garage, but where they are able to still pull heat out of the air, even at very cold temperatures, and then they transfer that heat through insulated water pipes into the storage tanks. And then those come in both multi-pass and single pass style water heaters. And there's commercial, large scale, and small individual residential scale. We're mostly I'm gonna give you some examples of a little bit larger family, multifamily scale, and then mostly we're gonna focus on the single family scale for this course to give you kind of that background. And that's just where we're seeing most of the kind of poor installations and misunderstandings. So we wanted to focus on that. So examples: split hydronic heat pump water heaters. These are single pass condensing units. The photo on the left is of a multifamily project we worked on that uses the Sandon or the Sanco 2, and these things are plumbed in series. And this is in the near Santa Barbara. It's fairly warm. The tanks are outside, so that makes sense. Then we've got a photo on the right-hand side using Colmac heat pump water heaters. And this is a roof-mounted system. And so in the foreground, you can see their space conditioning heat pumps. And then in the back are those Colmac heat pump water heaters. This is during construction. The lines aren't insulated yet, but the tanks are indoors. And this is more appropriate for colder climates, where the tanks need to be better protected and stay warm throughout the winter. And the nice thing about these split hydronic systems that use a separate water loop for the heat transfer is that you avoid having to run refrigerant lines throughout the building to those tanks. And also the refrigerant itself is minimized and self-contained at the outdoor condenser unit. And then these units are often labeled as such, like this Colmac is, that says, hey, this has double wall heat exchanger suitable for potable water connection. And then once this installation is completed, then all those hot water and return lines will be fully insulated.
Jennifer, for the Sandon installation on the multifamily,
Yes.
we had a question just confirming that the exterior installation of those tanks wouldn't be valid for a climate that freezes with frost protection. You would need to locate those inside.
Yes, that's right. And so this is that project, that specific project is in Santa Barbara, and they're so if you're in Monterey, some parts of Monterey are fine, but you're in the colder climates, you're going to be looking at like this type of system where the tanks are indoors.
And that Sanco split unit, it's still an air source heat pump, so you can really think of it. Well, similar to the mini split systems that everyone's familiar with, where the outdoor heat pump condenser unit, they're rated for colder climates, but the tank itself, you'd want to locate somewhere where it's not freezing.
That's right. And then the stand-ins for example, there are for colder climate installations, especially in some of the multifamily projects where it's including covered parking as part of the multifamily. Those stand-ins, I don't have any pictures of it, but they often can be mounted up high so that there's no opportunity for cars or trucks or vehicles to hit them. So they're wall mounted up high, close to the ceiling, and that tempered airspace is perfect. And then the stand-ins, they'll still operate to -20 degrees Fahrenheit. And so
Right.
that's often a way that they're done. And then the tanks are indoors, and they do as short of a plumbing line and very, very well insulated.
Yep.
Like this guy, that's even here when they're going from tank and into these tanks are well insulated, and the piping is very well insulated. Whereas, you know, the picture on the right, that it's during construction, they haven't even gotten that far yet. Okay, so in the 2025 code, there's part 6, section 110.3, service hot water, 1 through 6. Now they added 7 for specifically air source heat pump water heaters.
And Jennifer, that's a mandatory section, correct?
It's mandatory. And what gets a little confusing, we've had it come up already, is that when folks are looking for this, they've maybe heard that this is coming up. They can't find it in the multifamily section. They can't find it in the residential mandatory measures section. Then they go to the non-res mandatory, and it's like, where is it? It's way high. It's high up in the building tree, and it's in section 110. So before you get to the occupancy types is where the mandatory measures are for these, because all occupancy types, turns out, are incorporating these type of heat pump water heaters. So just kind of heads up on that.
Hard to find.
And then I included a lot of the verbiage here so that you would just have it, because you'll get a copy of the slides. And then also to help you maybe when you go back and look at it, if you need to look it up in the code book, you're going to have these actual references right here in your notes to go find it in the code. But kind of interesting. So for the air source heat pump water heaters, they've even gone so far as to say, hey, a backup heat source is required for systems when the inlet air is unconditioned. So if you're pulling the air from outdoors, or you have a situation where it's not conditioned on these integrated tank types, then you're going to have a backup heat source, which often can be the electric resistant elements, hence why these units often get the name hybrid, because they're heat pump and they've got the electric resistance elements. So that's one way to do backup. I've seen some creative projects where the backup heat was actually another heat pump, and the units were indoors or in a protected space that was open to the outside. When the weather was warm, it could take advantage of it, but then it had the heat pump for the winter. And it was an interesting idea. I talked to the CEC about it, and they said, yeah, it appears that it meets the code. So, we'll see. I think the creative solutions will be coming up, so the engineers who put that together, they thought it was a good solution. Part of the heat pump water heaters needing ventilation or inlet air through the evaporator coil and then exhausting the air is these units need a certain amount of volume of airspace to work with. Because if not, if you can imagine one of these units in a small room, self-contained, it will continually try and extract the heat out of the air, exhaust cooler air, extract the heat out, cooler air, extract the heat out, colder air, until it reaches a point where it can't extract enough heat out of the air, so the electric elements kick on and this room is very cold, which also means you lose more heat out of the tank itself to the super cold air. So as a result of poor heat pump kind of installations, not following the manufacturer's installation guidelines and recommendations, now some of this has been codified. So as a result, the code is explicitly telling folks that if they have an installation without ducts, they need 100 cubic feet per kBTU of hour per hour of the compressor capacity, or you have to do the minimum volume provided by the manufacturer. And then it also goes on to say that, okay, if you're in a small closet that doesn't meet those requirements, then you have to follow our new code requirements for permanent openings to a larger space, such as a louvered door, like in this example on the left. And then there's a formula that you would follow for that net free area, NFA, and you would calculate that formula for the door. And then in one of the blueprints, they've given a little more guidance on this, but they've also then defined the net free area and basically how do you calculate it when you look at a louvered door or a space that has openings. So all this again kind of is a result of understanding that these heat pump need air, warm air, room temperature air, could be garage temperature air, but they need air that's not too cold, not too hot, and plenty of it. And then if that's provided for, the units function very well. The other way to take care of that, if you're installing these in a closet, is to duct them. So here you might see a duct coming off of the top of a unit, but it's not flue gas, it's flexible, it's usually flexible, it could be rigid, but the new code says these ducts need to have an R6 insulation and they should be sealed at all the penetrations. These flexible ducts in some ways are good because it does help isolate the unit. When it kicks on, there's a vibration. And so the flexible ducts are not going to send that vibration through the structure. So it is a technique used to help keep these things quieter. And you can also use rigid duct, but it's recommended you have some part of it be flexible just to isolate the unit from vibrating into the structure. And then there's some considerations if you have both the inlet and the outlet ducted. You have air balance in this case across the pressure boundary, but if you only have one or the other ducted, then you'll want to accommodate it with a little bit further design. So if you're inspecting it, probably doesn't matter too much to you, but for the designers out there, that's something they should think about.
And then I just want to throw in that this clarification in the code we were really excited about because the number one thing we've been seeing is these units being installed without accounting for these ventilation requirements. And when that happens, the units just default into electric resistance mode. There's a whole conversation about the controls and settings. Jennifer might touch on that, but that's a whole nother world. But then often people are unhappy because they are running a tank electric resistance water heater, seeing high electricity bills, and they paid a premium for the unit that's just not operating for what they paid for. So previously it was like best practices. How do we get people to account for these designs? Finally, with this code update, we actually have something to point to and say, look, these are the limits, these are the thresholds, and how you need to handle this.
Yeah, exactly.
Hopefully we'll see better designs to accommodate these units, and we won't have such pushback.
Right, right. But that's in section 110.3, Title 24, Part 6. That's where you're going to find reference to some of these code requirements. For those of you doing the plans examining and code enforcement. And then just in general, kind of codes, guidelines, and some examples of installation. So yes, energy code, Title 24, Part 6, we just talked about. And the updates for the 2025. But then a lot of the heat pump water heater, it's of course going to touch on plumbing code, because we've got chapter 3 that deals with the protection of the piping, the materials, etc. And then chapter 5 deals with installation requirements, also including our seismic provisions, proper drainage pans, etc. And then because these are electric appliances, they will have to follow the electric code. So the guidelines we look at for the integrated heat pump water heaters, just kind of the parts and pieces and guidelines, is we like to remind the designers that the heat pump water heater tanks are taller than a standard kind of gas or the electric resistance units, because they've got that heat pump unit on top of the tank. The sound levels typically between 45 decibels on the low end and 55 decibels. Some of them might be a little louder than that, but most of them are averaging around 50 decibels. The higher end ones that are NEA tier 4 and 5 rated units are the ones that are hitting in around 45 decibels. So if sound's an issue, that's where folks should look for that. There is condensate, because the heat pump, as it extracts the heat out of the air and creates cold air, that leads to dehumidification, and it leads to condensation on the evaporative coils. And so that has to be taken out of the heat pump, which means that's has to be accounted for. So we often, we're going to be talking about floor drain or condensate drain that can be run into an appropriate location. Like if it's near your washing machine, you can add it to the discharge that your washing machine's going to have. And then the older units are needing around 700 to 1,000 cubic feet of volume, or the ducted vent kit, and the newer models are only needing 450 cubic feet. And so, and that 450 cubic feet is kind of in line with what the new 2025 code requirement is. So the units have gotten more efficient, and operating temperature starts around 45 degrees Fahrenheit, but some of the newer models are even going down to 37 degrees Fahrenheit, which again implies that these types of units need to be in a space that's semi-conditioned or naturally not going to get very cold. So it's really dependent on your climate location, what your strategy is going to be. Because for the colder climates that in the wintertime are getting, below 35, you're not going to be wanting to put these out in your garage. If your garage is that cold, you're going to have to figure out a way to put them inside your house. And then your heating system will counteract in a good way. But it'll make up for the small amount of cold air that gets pushed out of these units.
And that when you see a ducted, like for a lot of the climates in the CCR rent territory, a ducted intake from the outdoors when someone is concerned about the space. Even though it's allowed, if you're trying to use hot water in the evening, it's really not the best solution because just what Jennifer said, they're not going to operate well. So even if you did size the ventilation and design it properly because of the climate, you're going to run into the same issue where these units aren't going to operate properly.
Yeah, and
Oh,
right. So this example is the one where it says, okay, be mindful of your pressure boundary because here the exhaust, the cold air is being sent out. And this is a multifamily project, but these 2 units are using the semi-conditioned air of all of the kind of the maintenance, and it was next to the bicycle storage, and which is next to the office part of the multifamily project. So this room is much larger than what you can see in the picture here, but it's a semi-conditioned space that does have connection with, a greater amount of inlet air, and then they're just sending the cold air outside so it doesn't overchill the spaces, and so that can work too. So but the mechanical engineer had to kind of sort all that out. And then we have seen some cases where these units are being put indoors completely, and they're pulling from outside, they're exiting to outside, but like Grant said, that might not work very well for super cold climates. And for your warmer climates, I have seen people start to experiment with dampers on these things to figure out, if it's possible seasonally to change where the air is going and where the air is coming from. So I think there's still a lot of playing around with these units.
some experimentation still happening.
Experimentation, that's the word I'm looking for. Okay, and then all the heat pumps are going to have a control panel, and a lot of them will work with your phone, and you could put them into heat pump only mode. That hybrid mode is going to mean it'll switch back and forth between heat pump and electric resistance as it needs it. Unfortunately, well, let me say this first. You can put it in electric only resistance heating mode, which can be super useful if, for example, you need a fast heat recovery and you have a bunch of family showing up for the holidays and they're all staying with you, and you need to put it on electric resistance only so you can get your hot water faster and then put it back to hybrid or put it back to efficiency. But like Grant was alluding to, the unfortunate thing when some of these are being installed in super confined spaces without the proper ventilation, we've seen situations where the builder will just go, yep, I didn't design this, which again kind of comes back to why to get through the plan check, and then the architect didn't really know what they were designing for combination, and the builder didn't catch it either. So it's all still relatively new. So then once that thing gets installed, the builder goes, let's just put it in electric resistance only mode and leave. And
Yeah, there's also a world of to each manufacturer, they have different marketing branding for these modes, and they often tout this hybrid mode is the most efficient. And then they won't share what those schedules and thresholds are for when it switches back and forth. So there is a world of dealing with the manufacturer's install and operation that is actively being handled, and is a little misleading.
yeah, so something to be kind of aware of. I think we're getting the word out with everybody. And then one of the plumbers I know, his whole gig is he goes out and he gets a call like folks aren't happy with their heat pump water heater because of how it was installed. And then this plumber's more than happy to pull them back over to his favorite brand of water heater, which turns out is not a heat pump water heater brand. So there's that going on. So I do get to hear the horror stories of poor installations, but then there's installations that are work very well. One of our colleagues has a heat pump water heater. Well, a few of them actually, and they said they're great. They work fine. So with proper installation, it's all good. Care and maintenance, they all have a filter. Turns out not everyone realizes that the heat pump water heaters have a filter, and that filter is there so that the incoming air has some means of stopping some of the dust and debris from collecting all over the evaporator coil. And so they do need maintenance. The reason I bring it up is because, the installation instructions on almost every brand I've looked up all do talk about where that filter is, how to access it, and that you need clearance. So you need to install the plumbing and the piping and the electrical to meet the clearance. But even with really good builders, sometimes stuff happens. So here's a project I went out to. The builder was super proud because the installation looked really clean. And I was like, wow, this looks so clean. And I couldn't quite see on the top of the tank, and I couldn't see the stuff coming out. And so I reached up there. I ended up having to climb up on something to get a picture at the top. And I had the builder, I said, are you sure you could get the filter out? And he goes, oh yeah, you can get the filter out. We install these all the time. I was like, really? Like I dared him to show me that he could do it. And he reaches up there and he goes, God, cuss word, because it was like the installation was too clean. And so the reason I pointed out is this happens a lot. Like folks are proud of the job they're doing, and then, oops, they needed just a few more inches clearance on the top to get the filter out. Okay, so it's just something to be mindful about. One solution is A&O Smith on their newer models, and I think some of the other brands that are probably going to start looking at this too, is let's put the filter maybe in the front where we can slide it out, because apparently it's really common that filters were getting making it hard to actually do the maintenance required. So this one, the filter comes straight out. The other kind of problematic thing we see is sometimes during the construction, folks forget or don't realize that they have a condensate drain associated with these heat pumps, and that has to go somewhere. It can't just be floppy like in this closet installation on the picture on the right that I took. It has to go to a floor drain or an appropriate place. So and it's a requirement. So it's something to be aware of. Also, if you're in a situation where you're in an attic ceiling assembly or a floor ceiling assembly, subfloor, where you could get damage, then you've got the plumbing code that also backs this up with a pathway for drainage and drain pan. So that's kind of for your reference, and also a picture. Now, it's really not appropriate to just put your condensate line in your drain pan. It also needs to drain, and your drain pan needs to drain. So they all need to drain. So drainage is kind of a thing we're seeing that sometimes gets messed up. This is just an example of what some of these can look like when you have ducted situations. So for milder climates, or climates where you need to protect the space, you can have an insulated closet. And the architect kind of drew the proximate location of the heat pump water heater. But the reality is, when you install it, the heat pump water heaters have a control panel in the front. They have exhaust port, usually on the right. They have an intake, a lot of times on the top. And your closet might be a right-handed closet, a left-handed closet. And so the plumbers, the builders, they're the ones who are actually kind of trying to figure this out and figure out how they're going to deal with the ducting. So a lot of times what, in this case, the architect thought was a super, super generous closet for the heat pump water heater. It kind of took the whole thing because of the ducts. And this is what this can look like from the outside. This was a 2-story apartment. And so you had the ducts in that outdoor closet, and then air exhaust and air intake in the insulated closet. And this is doable again, because this is in a fairly mild climate. So like climate zone 3 and 5, on the Monterey side of the Wrens. But then once you start getting to the colder climate zones, then you're going to need to just monitor and figure out how cold that air is on these units, or go to the sanded type. So a couple more pictures of what interior ducted closets look like. And some of these pictures also just include other good stuff that I noted, like the air filter is easily accessible, the controls are easily accessible, the lines are insulated mostly, etc. Now, if that kind of system doesn't work, your split system heat pump water heater might be a better solution. It's a little more expensive, but you can have the tank completely indoors. You can have the compressor outdoors. They could be, everything can be well insulated. And that outdoor unit, the Sandon, uses CO2 as the refrigerant, and it can work to negative 20 degrees outside. So sometimes this really is the better solution.
I use these a lot in higher end residential construction when floor area is the premium. When someone's already got a set floor plan and they didn't account for that 700 cubic feet of air to locate this unit in, whatever the duct configuration might be, and it ends up stealing spaces. These units, you can put the tank, like on the far left, in really confined spaces. And so it can free up or accommodate a good system with a floor plan that's already been determined.
Yeah, that's right. And then you can just squeeze them into tight places. And the other beauty about it is there's no noise with those indoor tanks, because they don't have moving parts. They don't have a fan associated with them. And they're quiet, and they're well protected when they're indoors. And even though the refrigerant is a low global warming, CO2, it's also nice. It's self-contained in the outdoor unit. So if a leak ever were to occur, you don't have to worry about CO2 being in your house, because that's all self-contained outdoors. And it's just potable water that goes back and forth. And if it's really cold, you can set it up and work with the company to have the right mixture, so that you don't have to worry about freezing for those the heat transfer piping. And then just another example of what that can look like if you're don't mind looking at all the piping. And this was before all that piping got insulated. And you can easily put a cabinet around it if you don't want to look at it. Okay, now when it comes to plumbing distribution and recirculation, we have a lot to say. Grant and I come at it from the Title 24 Energy Code compliance side. And so technically, when you are looking at the plumbing distribution for a hot water heating system, a lot of that times it can be something that's mandatorily required, or it can be a credit, or it can be a penalty. And a lot of times when we get the drawings, it won't tell us whether or not there's a heat pump water, whether or not there's a recirculation pump in the system. Sometimes we don't know until after, but there are also ways to get, some better credit, like doing a FERS inspection, even if you do have the recirculation pump, and also insulating all the water lines. So, typically a 1 is neutral, something less than 1, like a point of use plumbing type, gives you a huge credit of 0.3. So it's like 70% better.
Jennifer, can I chime in?
Yeah.
So this it's literally a multiplier. This is, Tile 24 code design side,
Yes.
but that 1, that 0.3, that 9.8, these are taking whatever the baseline hot water budget that you're given when you're doing your performance model and just multiplying it by this distribution multiplier. So a 1 means you're just doing code. It's no credit, no penalty. It's just neutral. So then when you look at this little chart, you can see that for a home that, hey, we need a little credit. There's a few options, not a lot. And those actually do account for, I'm sure Jennifer's got some stuff on it coming up, actual design considerations. That compact design, that point of use, there's a lot that goes into that to be eligible to actually receive that credit. But more importantly, is you can see all these large numbers, and the green one is the biggest issue. So often, if someone tells me, yeah, no recirc pump on a new home, I say, great, no problem. I do the trunk and branch, standard 1, no penalty. Well, then at the time of install, inspector calls up and says, hey, there is a non-controlled recirculation pump. It's not in the tile 24. Can you put it in there? I go, yeah, sure. But it's going to be a 9.8 times penalty on just the hot water budget. Majority of the time, that makes the project not comply. So then you're chasing backwards, and it's this whole argument and everyone pointing fingers at each other. So we always try to get way ahead of this and try to talk about what options are available and get that solidified as soon as possible in our private work, obviously. But go ahead.
And then right, and then we say, okay, so you at least have to put in a manual demand control on it, and let's get a HERS rater out there, because that's like 1.6 penalty versus the 9.8. So it's less.
To that point, that manual is a push button, like at the fixtures, and the motion sense is with the fixture. In my experience, the motion sense don't work well, just from an actual use of them, and people don't like the push buttons. So this is something that homeowner, architect, contractor, and then code enforcement, it causes a lot of issues. And it's still a penalty even when you do that.
Yeah. So what with the heat pump water heaters anyway, we highly, highly recommend having compact or that point of use plumbing anyhow. And then you won't even need the recirc pump. But that again comes down to design, the kind of design questions and where you locate these things. But regardless, the manufacturers recommend that both the hot and cold water pipe on the systems are insulated. They recommend it, and we're starting to see some of that being called out in the code. And you can get a credit if all the piping is insulated, so that can help. For the single family side of the code, there's greater alignment with the plumbing code now with that energy code. And there's a minor kind of little update. I just want to point out that in the 2025 code update, the energy code points to section 609.12. So the section numbers changed from 609.11 to 609.12, just kind of FYI, but otherwise the language is really kind of the same. And so what the residential code side of it calls out is that the insulation thickness shall be at least as thick as the pipe diameter. But, you know, not all insulation's the same. I tried to show a picture of the really good stuff, and it's really thick and has a high R value. And then there's the stuff you can pick up at your local home do-it hardware store that's like pool noodle stuff that it doesn't work so well, but it can meet the letter of the code being the same thickness as the piping, just kind of FYI. But the have a picture on it. The multifamilies is a little different, and non-res is different for sure. They call that out with the R values as well. So sometimes, you know, some of the pipe insulation is mandatory, but you can do all of the hot water piping and get some credit for it. And then there are certain things that you're supposed to do that's listed in the HERS measures in order to get that credit. And your HERS rater is supposed to come out and look at that and then do their CF2Rs or the CF3Rs and take care of it. But the example on the right shows, you know, an installation where they insulated all of the piping, but they do have a recirculation pump, and this is for a multifamily, or might be
That was a non-res project.
A non-res project, sorry.
Yeah, that was a non-res.
Yeah, but still, it was like beautiful because they insulated everything, which like they're supposed, you should be doing that on the single family projects as well. And so on the multifamily projects, there's a table 160.4A that lays out that thickness and the R value that you're supposed to meet. For the 2025 code update, they still have that table. The table hasn't changed in terms of the values, but now because of the importance of what we're learning with the heat pump water heaters, they're explicit that the first 8 feet of inlet cold water piping from the storage tank also needs to be insulated, and that the insulation needs to be continuous, and that you have to have clamps attached to the outside of the rigid pipe insulation. The seams must be sealed. The elbows are supposed to be mitered or preformed. T's are supposed to be notched. You're supposed to have extended stem on your isolation valves, et cetera, et cetera. And here's some pictures of what some of that stuff can start to look like. And, you know, the person in this install job, they did have the pipe clamps, but they stopped the insulation, which is pretty typical. But the new code now is explicit for the multifamily. At least they're catching it there. They haven't put this into the single family yet, but the multifamily saying, nah, you have to run your insulation through the whole piping and put the clamp on the outside of it. And that these joints and elbows and places can't just be left to flare open. They have to be taped and sealed and mitered together. Point of use credit can really help. And just because, and what it is you basically have the hot water heater right where your hot water fixtures are. But to get this credit for new residential construction for larger homes, we often have to have more than one water heater to do it. And it is a requirement if you're going to use electric water heating for ADUs or an addition that are like 500 square feet or less. And then the new code basically just updates, instead of saying electric resistance, instantaneous rather, water heater, the new code 2025 just says electric water heater. So it can also be a small tank type. But what that point of use really looks like is right away, right from the water heater, you're going to have a manifold, and that manifold is going to reduce the piping size to, you know, 3/8 inch typical for a sink, 1/2 inch for shower, And then that length of piping in plan view is limited by the size of the piping. And if
Hood, I need you.
go ahead. Okay. So again, that we're seeing recirculation pumps showing up. Like in this example, this was from one of the HERS raters where it was installed, and then the person, code enforcement came and looked at it, saw it, point out to the HERS rater. Okay, so you get a call and then it has to be rerun. And at least with the HERS rating, you get a penalty, but not as large as you would have. And I believe then Paul told me the HERS rater, one of the HERS raters we worked with, they had other things they could do to mitigate for this and get their recirc pump in there, like more insulation, other places, etc. There are some mandatory requirements for that recirculation system that you do have to comply with the HERS inspection. And some of that has to do with check valves being required, and check valves with shutoff and isolation. So that check valve has to go between the tank and the cold return on the recirc pump, and then explicit to the multifamily is those isolation and check valves have to have the extension on the stem so that you can not stop the insulation short on either side, which was kind of what's happening with the short ones. So what this can look like, kind of that same project, but now with all the parts and pieces there. So you've got recirculation return line and your shutoff isolation valve, your recirc pump, your check valve. But what we're also seeing, it's a little squirrely. The manufacturers do not recommend this, but we've been seeing it in the field, kind of old school, is they go, oh, the drain port on the tank. Man, this pump, I need to bring it in. I think I'll put it into the drain valve here. And it's not recommended. It's not going to function properly because of the way the drain valve internal to the tank, the way that comes out of the tank isn't the same way as your cold water inlet is going into the tank, and it will kind of mix up it and destratify the tank. It just undermines the performance. So this is more of a FYI heads up. But on multi-family projects, explicitly, that's not allowed. But there is no code that explicitly doesn't allow it in single family dwellings. So it's hard because then the code enforcement person doesn't have a piece of the code to go to. But if you see this in multifamily, you could totally call them out on it. So example of what that kind of looks like. I don't know if you can tell what's going on, but sometimes this piping and everything gets convoluted. So you have your cold water inlet, great. This is another example of where they didn't quite do it the way they're supposed to. There's your tank drain valve hose bib, and then there's your recirc pump. And sure enough, they're sending the recirc back into that check valve isolation. Now, there is, they do have all the shutoffs and all that. But again, we're seeing stuff like this for single family. You can't on multifamily. However, like this project on the left, I didn't label it because I was really also wanting to point out other components like expansion tanks. But this one does follow the A.O. Smith's guidelines, where the recirc pump is coming into the cold water port at the bottom, not the drain port, which is allowed. That's good. In addition, this expansion tank is located on a cold water port at the top of the tank, which is allowed. And then the hot water comes out of the top tank. So they do have some flexibility. And so this one is plumbed properly. And this one is, I believe, for a multifamily project. And they also, there's other components like scale preventative devices that can be put in there, which was part of that cold water from the municipality. The cold water comes in there, but the return on the recirc cold down at the bottom through the cold port. And you might notice too that the ports are, they now, I'm seeing on the newer tanks, they're like a blue around for the cold water, red around it for the hot water, gray where the water comes out, not to be confused. For just, I put this in here too, because when it comes time to sizing a heat pump water heater, you know, you can refer back to the plumbing code in table 501.1, where that first hour rating and what you're allowed to do for the mixing valve and bedroom sizes. So it helps kind of understand what size tank you need. But again, we kind of recommend upsizing if you go with this lower voltage, like if you do get a 120 volt heat pump water heater. Again, now I'm kind of speaking to the general public or any of you who might want to get one. It's recommended to go up a tank size for those lower voltage units. The other thing that comes up for us lately is sound, and partly because folks are installing the units indoors. They might, one case I know of where the homeowner had an existing house and they installed it in their old water heater closet. And it just so happened the old water heater closet was in the hallway. And the unit they got, they started out with a higher end unit, and then the plumber they were working with, didn't recommend it, and only was working with a particular brand that didn't have a very good sound rating. So they're really disappointed. And they're not really used to having that cold air blow on them. So there is some stuff to get used to and to know, but for sound, you can look for the NEA rated tier 4 or tier 5. You could go to NEEA.org and look for the ones that are rated tier 4, tier 5, because in order to get that rating, they have to be under 50 decibel A to achieve that. And you'll want to look to install them in spaces that are acoustically isolated, and don't install them on the backside or along bedroom walls. For example, you install them on the ground level. Typically, it's going to keep things quieter than putting them up on a second floor, or we've seen some plans where people are thinking the best place to put them is in their super tall attic or a closet upstairs. One, it's water, so we just don't recommend you put it up there, but you know, sometimes you're dealing with a situation where that's not going to be an issue. So you need to design for it, and you can use isolation base, and then using PEX piping between the unit and the non-flexible other part of the piping can help isolate it. And then you can use seismic straps that are flexible, or sound isolation fasteners. And I think also if you're in a cold climate, this helps with sound, but it also helps if you're in a colder climate to insulate your tank from the floor by putting it up on R10 rigid foam base that's rated at 25 PSI. And if you want to get a little bit more information, you know, on how to deal with the colder climates also, there's some good tips on the Building America Solution, energy.gov website. And that kind of covers the bulk of it. But what we're trying to talk to plans examiners in terms of what you're requiring and the architects and engineers is to include more information on the plan set related to the heat pump water heaters. And especially if you know that you're going to be having HERS ratings, get that on the cover sheet. You know, some of the stuff, the specifics for heat pump water heaters that can really help with the installation, the code enforcement, the HERS rating, etc. And in the end, have people that are happy who are going to be using these products, is to include the dimensions of the heat pump water heater location in the plan so that everyone can see if there's going to be enough room, and to have plumbing notes in the plan set that specifically deals with pipe insulation and recirculation pump if they're having it, and distances. And a lot of times for residential sets, we're not seeing it. And also it really helps it to be brand specific, because interestingly enough, when the HERS rater comes out, the HERS rater needs to look at it in terms of which brand it is. And also when we do our Title 24 work, we can choose the specific brand, and sometimes you'll get additional credits if it's a more energy efficient brand. And then also indicating the ducts and locations and clearances if those things are used. And of course, to delineate where the condensate drain pathway is going to be. And this also goes along with also having them delineate the distance between, let's say, the exhaust air and the wall that might be nearby. Because also we've heard stories now where that exhaust, the manufacturer, they'll say, oh, you only need 2 inches of clearance on the sides. But when you're looking at a round tank, what does that really mean when something is the rear or the sides of it? So we're seeing closet installations where that exhaust port is facing a wall, and it's possible that you could get that wall so cold that you'll have some condensation issues on the wall itself. Okay, couple of resources. If you haven't read up on the 2025 code edition yet, you can get your copy of the 2025 code. You can link through all that at DGS, and you can get a copy of the Part 6 on the California Energy Commission website, and visit ccrren.org for the Codes and Standards program to access the Code Coach. And you can click on programs, then that'll take you to the codes, and click on the Codes and Standards program. And then there is, scroll down, you'll have the Energy Code Coach, and then hit complete the take intake form and fill that out. And we will answer your Code Coach questions. Okay, and with that, we have reached the end of the slide deck. We still have a few minutes for questions and discussion. And I'm also going to let Jess kind of fill you in on any kind of upcoming or what, the year 2026 might have in store for everybody.
Yeah, we had one question earlier, but Jess, if you want to do your quick wrap up, and then we'll spend the rest of the time chatting, seeing if anyone else has anything else they wanted to ask us.
Thank you. I appreciate that, Jennifer and Grant. Great training. I'm learning a lot as we go, so really appreciate your expertise here. And yeah, thank you so much for promoting our Code Coach service. We absolutely would love to help any of you that have, questions on the code. And you'll have experts like Grant and Jennifer at your disposal. So as far as upcoming trainings, we are at the end of the fall series. We know the holidays are coming, so we don't have any virtual trainings on the books just yet. But we are absolutely interested to know if there are training topics that are of interest to you. So we do have a short survey that we're going to run right now via the Zoom poll. And then you'll also get a follow-up email from me with the slide deck, the recording, and a general request for any other feedback. So with that, if you guys don't mind, if you just could complete the short 2-question poll for us, it's a big help. It is a part of our reporting that makes sure that we can fund these programs. So yeah, and if anyone has any questions, feel free.
Awesome. We had one earlier, Jennifer, that referenced drawing from the attic for venting on these units.
Yeah.
I know that's just a topic that has a lot of components to it. Is there any
It's been a long time, dude.
shorter how we're recommending and when to use the attic free ventilation air for your heat pump water?
That's what I told her right now. I know
Let's see. I'm not sure how to you start. Because you kind of like, it sounded like a leading question.
All right.
Well, I mean,
Wasn't sure. 'Cause
when
I
you're
think
doing
you have something in mind.
alterations, yeah, when you're doing alterations, people and also in like WUI zones, people have been coming to us asking, is it okay if I run these ducts, intake and exhaust from my attic? Is it okay if I exhaust into my attic, or I just pull air from the attic and exhaust to the exterior
Yeah, no,
through
that's
a
what
living
I
door?
remember right. It was pretty bad. And then there was the communication barrier was there, and
Sorry, I can't even tell who's
yeah.
chatting.
Really?
Can anyone else?
Ramen noodle.
Anyways.
Lance.
Yeah, I was gonna say,
we'll just-
as if
pretty
Jennifer's
worse, too.
the host, I think she does have the ability to mute a participant. I don't know. That's for us.
I
So.
don't think I'm the host.
I know.
I'm the host.
I
I just
just
don't
have-
see. Oh, I found it. I found it.
Oh, good.
Sorry. Sorry, as I was saying, there's potential condensate issues, dumping the cold air into the attic. Depending on unvented, vented attics, pulling that intake air can create pressure boundary issues. What's your kind of recommendations, Jennifer?
So where some of the folks have been experimenting with sending the cold air and using the attic has been in climates that are warm, or in the summer, if they're in a climate that's dry and also hot. So that could be a possibility. But once you go to non-vented attic assemblies, anyhow, it depends on what type of non-vented attic assemblies you're doing. The cold air is drier air, so that's something. It's the overheating times in the summer where your attic might be 140 degrees. So introducing periodically some cold air into that space that's drier and also colder seems to be working really well for some of those projects. You just don't want to introduce colder air in the winter if you're already trying to keep the place warm. So it's going to be a little bit climate specific.
Yeah.
I still think that if you're in a really cold climate, when I say really cold, to us, the Sierras, that part of our whole, CC Ren is cold. We're used to being on the coast of California. And in those cold areas, we're talking about putting your heat pumps in basements inside your house, or going to a split system.
Yeah. Okay, great. If anyone else has questions, feel free to unmute, shoot it into the chat if you want to. We got a couple more minutes, so any topics or clarifications, feel free.
Yeah, and also I'm really curious if any of you want to, I can end the slideshow if any of you want to, oh yeah, I guess I'll do the very last slide too. You go, ta-da! But if there's a few of us that are here, that want to unmute or chime in or tell us about what they're seeing, what they're seeing in the field. I'd love to know about that. Like, what are you guys seeing? Do people really know how they work? Are the installations very good? We had a code question come out not too long ago where a code enforcement official was wondering if what they should do because someone installed a heat pump water heater inside a metal cabinet, like metal closet, on the outside of their garage. They wanted to protect it, but now the unit itself is basically outdoors. And, those kinds of things get tricky. And so probably one of the main things is that the condensate drain was just running across the walkway, which then turns out that's like a building code issue as opposed to the energy code or plumbing code issue. And if there aren't any other questions, we're happy to let everyone go on time as well.
Yeah, Jennifer, I just wanted to add, this is Pam.
Yeah.
If any building department feels like having an in-person, maybe demonstrative training, if they're interested in that, either specifically on heat pump water heaters or other topics, we would love to hear about that and certainly would consider bringing training to, building departments across our region. So just as an FYI there.
Yeah. Yeah, that's great. I know one of the jurisdictions in our area, they're looking forward to that because there really are a lot of questions about heat pump water heaters. There's so much for code enforcement, plans examiners, the builders, everyone to know about. And these things still are relatively new. So we haven't really seen like all the ins and outs and iterations of it. But when we were at Pam, when we were at and Jess, when we were at KBEX conference recently, right? I was super excited to see the manufacturers really talking up how they're getting together with more code enforcement folks to really iron out some of these things and really trying to find out more what people are seeing and how they're getting installed so that they can inform, the manufacturer side of it. So I see all that as positive, but it does mean we're all on the learning edge of everything still.
Okay, I'm not seeing anything come through, so
Okay.
thanks everyone for attending. See everyone on the next one.
Okay, thank you. I appreciate it.
Yep, appreciate you. Bye-bye.
Bye.